This is Bridges, section 5.3, part 2. So in part 1, we learned about multiplying polynomials in its most basic sense, either by foiling or by using the little box thing. Anyway, the idea here would be that we want to look at some things that have special forms. Okay, so if you notice here, I've got practically the same binomials here, except for the fact that one of them has a minus and one of them has a plus. I don't really like that. But anyway, so let's just say I FOIL this out. So I take 3x and distribute it to both of those. We shake the hands or whatever. And so 3x times 3x is 9x squared. And then 3x times 2 is 6x, so we add that. And then I take this negative 2 and distribute it to both places. So this would be minus 6x when I take the negative 2 and multiply it by 3x. And then minus 4. Well, if you notice, these middle two terms cancel out because 6x and negative 6x makes 0. And then you've got 9x squared minus 4. And so that would be your solution to this one. Now look at this one. Again, same sort of thing. See if I can pick a better color here. So this and this are practically the same. The only issue is you've got a plus here and a minus there. So you have opposite sign on each of those. So let's see what happens when we multiply this out. Well, 6 times 6 is 36. 6 times negative 5x is minus 30x. 5x times 6 is plus 30x. And then 5x times negative 5x is minus 25x squared. Once again, notice that the middle terms cancel, and I get 36 minus 25x squared. Well, that's a pattern. And what happens is, if you have anything that you're multiplying that looks like a plus b times a minus b, that always works out to a squared minus b squared. It's what's called the difference of two squares. Now, let's look at something slightly different. So if you notice here, you've got this squared here, and you've got this term right here, which has 2x plus 5 in it. Well, if you recall, when we were working in section 5.1, you'll recall that if I had like 2x y squared, and I want to raise that to the second power, what I can do is I can just basically square all the pieces and I get 4x squared y to the fourth. Well, that's if you just have multiplication in there, which in this case, we don't have multiplication in there. We've got addition. So, as a result, what we need to do is we need to approach this a different way. Well, if you square something, just like if I have x squared, that equals x times x. So what I can do here is I can just go ahead and rewrite this as 2x plus 5 and 2x plus 5, and then go ahead and multiply it by itself. So you can FOIL that, Or for those of you that like the little box method, here I'll do one for you. So there's 2x plus 5, 2x plus 5, 4x squared, 10x, 10x, 25, because that's, of course, 5 times 5. 5 times 5 is 25. 5 times 2x is 10x, so on and so forth. So, now all I have to do is combine my like terms. So I've got this 4x squared, nothing goes with that. That's gone. Then I've got 10x and 10x, which when I add them together makes 20x. And then I've got 25. Now, the pattern that we're using for this would be a plus b squared equals a squared plus 2ab plus b squared. If you don't remember that, or you can't, or you have a hard time figuring out how to do that, just FOIL it with itself. You'll get the same thing. Now, let's take the same approach on this one. X minus 6, write it twice, multiply it by itself, shaking hands, foiling, doing the little box thing, whatever you want to do. So, x times x is x squared, x times negative 6 is negative 6x, then negative 6 times x would be negative 6x again, and then negative 6 times negative 6 would be plus 36. And if we combine our like terms, we get x squared minus 12x plus 36. And the only difference here is, if you notice, we started out this problem with a minus right here. And so instead of having a plus here and a plus here, you end up with minuses in both of those spots. So if you take a minus b quantity squared, that's a squared minus 2ab plus b squared. And again, only use this if it's helpful to you. If it's not helpful to you, just write this whole thing out like this. Okay? It'll take care of itself. So, there's one other thing I want to show you. What happens when we want to cube something? Well, it just so happens that just like when we squared something, if I write it out the appropriate number of times and then multiply it, then that'll take care of it. I can figure out what that is. Note that I can't take this 3 and distribute it like we did before, because that's not multiplication, that's addition or potentially subtraction in there. That's why we have to do it this way. Now, having said that, technically speaking, if you're a box person, you could make a cube out of this and 3-dimensionally multiply stuff together to make this work. That's really hard to draw on a flat piece of paper. So what we're going to do instead is we're going to take these first two, we're going to multiply them together, and then we're going to take the answer and multiply it by the last one. So, if I multiply these first two together, I'm going to have x times x and x times 4. So that would be x squared plus 4x. Then I'm going to have 4 times x and 4 times 4, so that would be plus 4x plus 16 times x plus 4. If I combine my like terms, that makes x squared plus 8x plus 16 times x plus 4. If you wanted to do this with your little box, you could, or you can just FOIL it out. x squared times x and x squared times 4. So that would be x cubed plus 4x squared. And you'd have 8x times x and 8x times 4. So that would be plus 8x squared and then plus 32x. And then you could take your 16 and distribute it. So then I'd have plus 16x and plus 64. And notice that if I combine my like terms here, that would give me x cubed plus 12x plus 12x squared plus 48x plus 64. And basically that's all there is to doing these special forms, okay? And if I scroll down a little bit, there's an assignment. Write it down and work on it. Yay.